So solve each using algebra. You must show work receive full credit. Obviously, you don't, but yes. Solve each equation. Be sure to find the real solution and the extraneous solution. Just to remind me, what does extraneous mean?
Ones that are not actually
Does not actually work. It's what you people call fake. Okay, there you go. All right. Does not equal, yes. Okay, so what we're gonna do is solve. Now, we want to get the radical by itself. So first thing we're gonna do is move that 6 to the other side. So we're gonna have square root of 22 minus 3x equals x minus 6. Now we're gonna square both sides to get rid of those square roots. So when we do that, we're gonna get 22 minus 3x. And then we're gonna multiply this out. Okay, at this point in time, I assume that you know how to distribute. Okay, so when you do that, you're gonna get x squared minus 12x plus 36. That's FOIL. That's that distributive property, right? Yes, ma'am. Now you're gonna move the 22 to the other side. And we're gonna add that 3x to the other side. So we're gonna have x squared minus 9x plus 14. Struggle. Now, we are going to factor this since it's a quadratic. So we're gonna say a times c, which is 14, but we're gonna add it together to get negative 9. So what two things can I multiply together to get me 14, but add together to get me negative 9?
2 and 7.
Negative 2 and negative 7. So that's going to give me x equals positive 2 and positive 7. Everybody catch where I switched the signs? I heard mixed reviews. Okay.
So it cannot be negative.
So no, it's not that. This, we would take and write x minus 2 and then x minus 7. And we would set those both equal to 0 and solve. So that would give us x equals 2 and 7.
So you do the same thing if they're positive?
Yes, you would switch them. Now, you do have to plug back in and check your work. Okay, so when we check, we're going to plug 2 back in, and then we're going to plug 7 back in. So we're going to plug 2 in first, and that's going to give me 6 plus the square root of 22 minus 3 times 2. And is that equal to 2? So 22 minus 6 is going to give us 16. Yeah. Square root of 16 is 4. 6 plus 4 gives me not 2. So 2 does not work. Okay. When we plug in 7, we're going to plug 7 into the equation. And so that's going to give me the square root of 22 minus 21. 22 minus 21 is 1. Square root of 1 is 1. 6 plus 1 is 7. That doesn't work. Oh, I'm sorry. I was just checking to make sure that like y'all were paying attention. Okay, so it does work. So our final answer is just going to be x equals 7. I had a lot of questions about this one, so let's pay attention. So the time it takes for a pendulum to complete one swing can be found by this formula, where time is t and L is the length of the pendulum. If the pendulum takes 12.56 seconds to complete one swing, how long is the pendulum? So we're going to plug in 12.56 in for t. Okay, so we're going to go ahead and do that now. And we're solving for L. Okay. Oh, okay. Is we're going to divide by 6.28. Okay. When we do that, that's going to give me 12.56 divided by 6.28 equals the square root of a L divided by 32. Now we need to get rid of the square root. So we're going to square both sides. Okay. Right. And when you do that, you have 12.56 and you're going to divide it by 6.28, which gives us 2, and then 2 squared is going to give us 4. equals L divided by 32. Now we're going to multiply by 32 on both sides. And that's going to give me L equals 128. So we got the formula represents the radius of a cylinder where R is radius, V is volume, and H is height. This is formula to explain why the volume of a cylinder, I'm reading, increases more when the radius is doubled than when the height is doubled. Okay, so what you're going to do here is two different solutions, different problems. Okay, one you're going to double the radius and one you're going to double the height. Okay, so watch this. So 2R equals the square root of V divided by pi times H. Now you're going to solve for V. So all I've done is I doubled the radius. Okay, so I'm going to square both sides. And that's going to give me 4R squared equals V divided by pi times H. I'm going to multiply by pi times H on both sides. And that's going to give me V equals 4 pi R squared H. You're going to do the exact same thing from the original, but you're going to double the H. So watch what happens when we do that. Okay. I'm going to square both sides. And so that's going to give me R squared equals V divided by 2 pi times H. Now we want V by itself. So we're going to multiply by 2 pi H on both sides. Sorry. I'm assuming that y'all started on these problems.
Yeah, absolutely did.
Awesome. Great. Okay, so between these two, we're trying to explain why the volume increases more when the radius is doubled than the height is doubled. Okay, let's think about it really quick. If the radius is doubled, that means that it's wider, that's going to cover more of a volume. Notice the difference between these two. Very similar, but we got 4 out front versus 2 out front. So it is literally double of what this is. Okay. Huh? Volume is kind of like double. That's not really a thing, but yeah. Okay. Last problem on the back. All right. Solving for R. Yay. R. This one definitely will be. Yeah. You are all the things. Okay. So what we're going to do is we're trying to get R by itself. So we got to square both sides first to get rid of that square root. And that's going to give me 2 pi squared times R divided by F. We're going to multiply by F on both sides. That's going to give me 2 pi squared times R equals P squared times F. Okay, if you write these backwards. We still want R by itself, so we're going to divide by 2 pi squared. Divide by 2 pi squared. So that's going to give me P squared times F divided by 2 pi squared equals R. Now, we talked about rationals for a hot minute. We just haven't gone back over them in a while. So rational functions are going to have anything that's in a fraction form, right? So the first question that we're going to do is number 26. Okay. Now, we want to add these. Okay. So we're going to try to combine like terms. Well, they have to have the same denominator, right? If they do not have the same denominator, then what we're going to have to do is we're going to have to multiply by the opposite denominator. Okay. Huh? I would. Yeah. Okay, so this guy over here has an X. This guy has an X. Okay. So we're going to multiply this one by 5X in the top and the bottom. And then we're going to multiply this one by 4. Oh, I'm sorry. This one already has an x squared. Tragedy. No.
Why does it say unit 4A?
Because it's very similar to algebra 2. Okay. So we're going to multiply this one by just 5. And this one we're going to multiply by 4x in the top and the bottom. The reason why we're just going to multiply by 5 is because it already has the x term with it. Does that make sense? Like this one already has that x squared. So you're going to have both of them squared. So think about it this way. 4 times 5 times x squared would give me 20x squared in the denominator, right? Same thing over here. 5x times 4x would give me 20x squared over here. All right, so now we can make this into one fraction. Okay, so this is going to give me 30, because 6 times 5, plus 2 times 4x, which is going to give me 8x. Okay, now we really can't simplify this anymore, except we can divide it by 2. So this is going to give me 15 plus 4x over 10x squared. And that's it. That's all we can do. I know, crazy. 27, you're going to work the same way, except you got subtraction. You want to take a moment, try 27, and then we'll check our work. Okay, I'll give you about a minute. So this is what I got. This is what I got. This is what I got. Ready? Because we're not going to do every single problem because it's a repeat. I give you extra problems just in case you want to practice. I'm going to do this problem right here. Okay. First thing you want to do on this one is you want to factor the denominators. Okay, because you're trying to see if they're the same or have pieces that are the same. So down here, we're going to factor this guy. And that's going to give me a times c, which is -4. B is 3. So what two numbers will make that happen? 4 and -1, right? Wow. Oh, I'm going to rewrite this as x minus 3 divided by x plus 4 times x minus 1 plus 2x divided by x plus 4. Now, are these the same denominators? No, they're similar though, right? So we're going to take x minus 1 and we're going to multiply it over here in the top and the bottom. I know. Crazy, right? Crazy. Okay, so now we're going to kind of combine this and put it into one fraction. So that's going to give me x minus 3 plus, and we're going to distribute that 2x. So that's going to give me 2x squared minus 2x. We're going to divide it by x plus 4 times x minus 1. I'll give you a second to catch up and then I'll keep. All right. So now that we're here, we're going to combine like terms. So that's going to give me this. Okay. And in the bottom, we're going to leave this in factored form. Remember, you always want to check and make sure and see if you can like cancel anything out or if you can factor it at all. In this instance, we're going to check and make sure. A times C is going to give me -6. B is -1. So what two numbers will make this happen? Ooh, good try. Good try. -3 and 2. So even if we put this out in factored form, that would not cross anything out. So this is our simplified form. Okay, so we're going to go ahead and do 2. So we're solving for x on this one. Okay, so we're going to cross multiply in order to solve for x. Okay, so we're going to multiply this way. We're going to multiply this way. So we're going to do 5 times x minus 5. And then 4 times 15. So again, we're cross multiplying. All right, so 4 times 15 is going to give us 60. And then we distribute this guy, and that's going to give me 5x minus 25. I'm going to add 25 to both sides. And that's gonna give me 85. Good try though. And we're gonna divide by 5 on both sides. And that's gonna give me 17. Yeah. Now, one thing to remember, you need to make sure that you plug back in and make sure that it works. If we do plug back in, that would give me 12 over 15. Is that equal to 4/5? Yes, it does. Okay. Can you try number 4? Ready? Oh, okay. All right. So we're going to cross multiply. That's going to give me 15 times x minus 6. And then 3 times negative 2x minus 2. Okay. We're going to distribute. And so that's going to give me negative 6x minus 3 on that. I'm sorry, minus 6. I can't talk, so just look at what I'm writing. Okay, so over here.
90.
Oh, okay.
90.
Okay. So now we're going to get x's on one side, numbers on the other. That's going to give me 21x. Over on this side, if I add 90 to both sides, what is that going to give me?
84.
Okay, and then I'm going to divide by 21. That's equal 4. Why is it a question? 4. Okay, and then you want to make sure that it works. So this is on the back. Okay, so in the graph below, how many total roots and how many real solutions does the polynomial have? Okay, so really quick. Real solutions, how many times is it cross the x-axis?
1 5.
Okay, that's the number of real solutions. So we can go ahead and get rid of those 2. This is on the back. Okay. Now we have things called real roots, and we have things that are called complex roots. Complex has the I. Okay. Now complex comes in pairs. Okay. But we can go ahead and get rid of A because it's not a pair. And we can also get rid of C because it's not a pair. So what's our answer? Okay, so when we add all of these together, okay, we're going to have 1 right here. And then we have 1 real, right? So that's going to give us 3 in total because 1 real plus 2 complex, thank God for Jarrett, means 3. Okay, so select all the polynomials that have exactly 5 roots. Okay, so that means it's going to cross the x-axis, or not necessarily 5 times. Okay, remember, because we can have the complex and we can have real. Okay, so what I want you to do is I want you to take each of these and graph it. If a couple of people want to take the first 3 and the next couple take the last 2, then we can all graph it together. Because I'm going to ask you a question in just a second. So right here, when you graph A, how many times did it cross the x-axis? The first one? It's going to cross 3 times, right? So it's going to cross at like 3, -4, and -6, right? So that's not going to have 5 roots. No bueno. Okay. On this next one, okay, that's going to cross 3 times. No bueno. Okay. What about on the next one? 3 times? Yeah. Okay, so still no. The next one, I know it crosses at least once, right? Yeah. Okay. Now, one thing that I need you to pay particular attention to is this exponent. That's your highest exponent, which is 5, right? Okay, so it's going to have 1 real, and then it has to have up to 5 solutions. Does that make sense? Yeah. There could be 4. Is there like swoops? Yeah. Okay. So that's going to be 5 roots. Okay. On the last one, when you graph this one, I think these cancel out. You would only have 3, right? So D would only be our answer. But y'all are absolutely tragic on these exponent rules. Yeah. Okay, so let's kind of go over them really quick. Okay. Looking at this first one, you kind of want to divide this up into numbers and then letters that match up and then kind of go from there. So let's go ahead and look at the numbers first. 10 and 12. What can we take out from 10 and 12?
2.
2. So we're going to divide 10 by 2. That's going to give us 5. And then 12 by 2, and that's going to give us 6. Okay, so we're going to have a 5 in the top and a 6 in the bottom. Now, when we have a to the 4th power in the top and a to the 8th power in the bottom, when they're across the division line, you are going to subtract. So what is 4 minus 8? Okay, so that means I'm going to have a to the negative 4th power in the top. And we'll talk about the negatives in just a second. For B, we've got 7 in the top and 5 in the bottom. Again, we're going to subtract. So that's going to give me b to the 2nd. Coming back to that negative exponent, mathematicians don't like negatives in our final answer. So we're going to switch this guy to the bottom. So we're going to say 5, 6 is going to be in the bottom, a to the 4th is going to be in the bottom, and then b to the 2nd is going to be up here. Ta-da! That's it. Yep. Ta-da. All right. We're going to work on number 2 in just a second. I just write that. All right. So on number 2, what we're going to do, same thing. Numbers, we're going to focus on first. So what can we take out from 18 and 24? 6. Okay. So 18 divided by 6 is going to give me 3 in the top. 24 divided by 6 is going to give me 4 in the bottom. Okay, now we got a whole mess with all these letters, right? So let's look at A first. Okay, imagine if we took all these other letters off and we just looked at A. If we have a to the negative 3rd, and then we have a to the 2nd, you can do this one of 2 ways. You can go ahead and subtract the exponents, or you can move that 3 to the bottom. And so that's going to give me a to the 2nd, a to the 3rd. And now we can add those exponents, which will give me a to the 5th. If you just wanted to subtract them, you could have gone -3 minus 2, and that would have given you -5. And then you would have moved it to the bottom. So you could have done it either way. Now, for the next one, we've got B. To the 2nd power and to the 5th power. We're going to subtract. So 2 minus 5 is going to give me -3. And so that's going to be b to the 3rd in the bottom. C, we've got 6 in the top, 4 in the bottom. So that's going to be c to the 2nd. Ta-da. Wow. Ollie, not you having to like. Oh. All right, the next one is a little bit challenging. Okay. Ready? Oh, it's definitely recording me as I thought it was. Okay, so we have an exponent raised to an exponent raised to an exponent. Okay, so we have 1/6 raised to the 2nd power. We're going to multiply those. Okay, so 2 times 1/6 is going to give me w raised to the 2/6. On the bottom, we have -2/3. Let's say negative. Yes, it does. Raised to the 2nd power. So that's going to give me w, and that's going to be -4/3. Now, since it is negative, we're going to move it to the top. Okay, so that's going to give me w2/6, which can simplify to 1/3. So we're going to go ahead and do that. We're going to simplify this to 1/3. And then we're bringing that 4/3 to the top. Well, now since it's on the same side of the division line, we can just add the fraction. So that's going to give us w to the 5/3. In radical form, we want to say the cubic root of w to the 5th.